Hi everyone and welcome back to another video. So what is this object-oriented programming thing? Well, if you're new to Python, a lot of the code that you might see and write is written in quite a procedural way basically. It'll run line by line and it'll be like do this, then do this, then do this. No real surprises there, to be honest. But that does introduce some difficulty. It makes it quite a static thing. It makes it hard for other people who might be on your team or your mates, I guess, to incorporate your code into theirs. And it also means that the code isn't very interactive if someone wants to use it. So another style we could write our code in is object-oriented programming. It lends itself nicely to interactivity, but it can also be used to sort of structure your code in a nice way, keep it consistent across the code base, that kind of thing. And people who are new to Python might not be familiar with writing code in this way, what advantages it brings, when you might want to write code using object-oriented versus just a traditional functional way. So that's something we'll talk a bit about. I think in the field of data science and machine learning in particular, it's quite a nice skill to have in your tool belt, I guess. Data science and machine learning code can inherently be quite messy. Like projects can end up, sprawling all over the place really. So just having some skill to be able to make things consistent is good to have. For example, you could use it to keep your data engineering pipelines and your machine learning modeling pipelines all nice and consistent, which is pretty cool, I guess. I don't know. So first we're going to start by looking at the absolute basics of classes, what they are, how we instantiate objects using those classes. We're going to look at things like inheritance, classes that inherit from other classes, and we can use that to sort of help keep code consistent and stuff. And we're going to look at how this might be implemented in a more practical way, when you might favor the functional approach versus the object-oriented approach. And yeah, by the end of this video, I hope you have a good foundational understanding of object-oriented and you can implement that in your own projects. Thank you for watching and let's get started. Hey guys, welcome. So we're at the desktop. As we talked about in the introduction, we're going to learn about objects and classes and all that stuff. But rather than just sort of sit down and, learn dictionary definitions, I think we should just sort of get started coding and stuff. And it's one of those things that's a bit easier when you can see it and when you actually start writing the code. So what I'm going to do is I'm going to just open up a terminal here. Now, I'm assuming at this point you have Python and stuff installed. If you don't, I'll put a link in the description to where you can get that. But once you have it installed, you should then be able to do a pip install a Jupyter Lab, for example. And what that will do is that will install something called Jupyter Lab, which lets you use Jupyter Notebooks. And that's what we're going to sort of start writing some of our code in. I've already got it installed, so it just starts spamming me with requirement already satisfied. And all that stuff. So in order to start it, what we can do is just type Jupyter-lab. Now, that'll then do this thing. It should just open it in a browser for you automatically. So when you first open this up, you'll see an interface that looks a bit like this. You can create your notebook by clicking on one of these buttons. I've already made one beforehand, and that's running. But all I've done here is just put a nice title, so you're welcome to do the same. Now, a lot of the stuff we're going to do, you can do in an editor of your choice, really. In fact, something I want to talk about towards the end of this video is something we're going to look at in a different editor. But I sort of like doing these in a Jupyter Notebook simply because it's nice and easy to see. It doesn't have too much stuff all over the interface to confuse people who might be newer to this kind of thing. So yeah, feel free to follow along. I'll probably upload this and add some nice commentary and stuff to it afterwards to my GitHub, so I'll post a link to that as well. Objects, classes, what's all this about? I think to start just sort of from first principles, right? It's good to define how you might want to sort of represent somewhat complex pieces of information. You can represent simple pieces of information, using numbers and strings and things like that. So, if you just wanted the price of something or the name of something, you can use strings and numbers in Python. I'm sure everyone can say, name of something equals something, right? What if you wanted to represent something a bit more complicated. So I'm not sure exactly why I've come up with this example, but it's all I can think of right now, to be honest. Say you are working at a fast food chain, I don't know, and you want to define exactly what appears on the menu, right? Say you work at McDonald's, I don't know. One way you might want to, and let's say you're working in their tech department. They have the touch screens and stuff now where you can order food and stuff on there. So let's say you're trying to represent food items that someone could order. So what we can do is, if we wanted to represent the individual objects on that menu, we might start with, I don't know, nuggets, right? So nugget equals, what's the name? Let's say it would just be called nugget. How many calories does it have, for example? I don't really know, 100? Sounds like a lot for a nugget, I don't know. And then, maybe we want some other type of information, maybe the price. So this would be, a floating point number maybe. Let's say one nugget is 0.79. Again, no idea. And then maybe we have a true false, whether it's on the saver menu or not. Then you might want to represent a cheeseburger, right? That one is on the saver menu, I'm pretty sure. So if I put cheeseburger, let's say 500, let's say that costs 99p, and that is, right? So, we could do something like this to represent these objects, right? And, we can run that. But the problem with this approach, right, is it just becomes a bit convoluted. Like if you just saw this in passing, could you really tell that this is referring to the number of calories in the cheeseburger, for example? So things like that is what can introduce errors, really. It's not very flexible. And so this is something that might be suitable to represent as a class, right? Basically, long story short, a class is something that we use as a blueprint to create objects. So how do we start by defining a class? Well, we can just say class food. That's the keyword, really. And if you just want an empty class, like you don't want anything in here, you can just use the keyword pass in Python, which basically means, do nothing. So this is a class. Now, once we have this class, we can instantiate an object. Our new cheeseburger is going to be an instance of food. So if I run that, I now have this, which is an object instantiated from this class. If I just show you what that is, it's basically just telling you the memory address at which this object is located. Now, this isn't a very interesting class, really. So let's make it possible for us to encapsulate all of the information that we were providing before. So classes typically have what we call a constructor or an initialization method, right? So they don't necessarily have to have it, but when you define one, you would define it with this syntax. You would do def __ init, and then you'd have your arguments. This is a special type of function. This one will run automatically every time you instantiate an object of this class. So it's always the first thing that will run when you create a new food item. Now, the first argument we're going to want in here is something called self. You're going to see self quite a lot here, and it even gets a nice special color in this editor. This self argument is referring to the object that you create, essentially. It's not been created yet because this is just a class, right? And all that's saying is whenever you run any of these methods that we define in this class, the object itself needs to be passed, because what we're going to do with some of these methods is modify some of the properties of that object. In fact, we're going to do it right here. But then after that, you can supply other arguments as well. So we're going to supply some of the stuff that we were doing before. So name, calories, price, and saver menu, which is going to be our Boolean. Now, as I was just mentioning, we want to modify or set properties of the object that we end up creating. And we can access those through dot syntax, essentially. So we can do self dot the name of any property that we want to set. So I just want to set the name property to the name that we provide. And this is also quite a common thing. You might just see initialization functions like this, where an argument is provided to the initialization, and that is then set as a property of the object. You can do more interesting things here if you really want. But for now, let's just do this. So all of these things I'm providing are being set as properties of this self thing. So these are what we call instance attributes, okay? They're created when we create our object, and they're going to be properties of the object. Now you can also get these things called class attributes. Now they're, in a similar sense, you can have strings or numbers or things like that as class attributes. But those are attributes of the class itself, the blueprint. The objects that you create will have those attributes as well. But what I'm saying is this is a property of the class directly. So for example, you could have something like restaurant equal McDonald's. This isn't affiliated with McDonald's, by the way, but yeah. McDonald's, if you are watching and you want to sponsor this or send me food, I guess, feel free. These are basically being set as the property of the object that you create, whereas this is going to be common to all objects that you create because it's a property of the class from which that object was created. So let's run this print. Now, if we use that blueprint to create a cheeseburger by trying to do what we did before, it's going to throw an error, I hope. Yeah. It says it's missing the four arguments because, yeah, the name, calories, price, save a menu. We didn't provide any of that. So let's do that. Let's just take all of these. And now we have our cheeseburger. So you see, when you instantiate the objects, the arguments to the init function essentially go into the object creation directly. You don't have to run the init function exactly. Now, once we have this cheeseburger object, if we just run this, we'll see, again, it's stored at this memory address. But using dot notation, we can actually access some of the different properties that we set. So we can get the name, for example. We can get the calories, and so on and so forth. So I'm sure you'll agree that this is a much better way of representing our menu than, say, this, right? We can also access the restaurant. But one special thing about the class attribute is we can access that even without creating an object. So we can do food.restaurant, for example. I really am struggling to spell restaurant in this tutorial. There we go. That tells you there that even when there's no objects created, this McDonald's is a property of the class. Whereas you can't access the name. That's not a thing. There's no name attribute to this. That only exists when we create an object. So I just want to make that distinction between class level attributes and object level attributes quite clear. So I guess sometimes it's obvious, sometimes it's not obvious when you want to set a class attribute, something that's going to be common across all the different things that you create, like McDonald's in this case, or something that's going to vary across the different objects. So now we're going to talk a little bit about instance methods, because not only can we have properties, we can also have methods that are associated with this object. We can make this object do things rather than just use it as, some kind of glorified dictionary, basically. So for this, I'm actually going to switch examples a bit. I don't really know where I was going with the whole McDonald's thing, but whatever, it's there now. A lot of people, when they're introducing object-oriented to people, like to use cats and dogs and things like that because they just lend themselves quite nicely to this kind of example. So I'm going to do the same, actually. So we're going to switch themes here a little bit and talk about dogs, I guess. So now let's start creating a new class. Let's call it dog. Now, again, I'm going to define an initialization function. Remember, the first parameter is always self. Let's just say name and age, just so we have a couple of parameters. Now, again, I'm just going to set the name property of any objects we create to the name we provide and the age to the age we provide. However, we can now associate methods to these objects by defining them in the class. So we can say, define another method in this class. We want to define a description method because we're writing a video game or something and we want this to be printed out when we interact with the dog or something. I don't know. Now, again, every method we want to start with self, and I'll talk a bit more about this in a second. But because we are providing this self, we are providing the object, we can now access the attributes of that object. And I actually want to do that here because I want to just do a simple print. I want to print, let's create an F string here. Self.name is self.age years old, for example. It's not a great description, but There we go. And yeah, let's make another one. Let's call it noise. Animals make noises, right? So we're just going to make this guy say woof. So now this dog class has a couple of methods associated with it. So now let's run that. So we have that blueprint there. Now let's create a new dog. Let's call it my dog equals dog. Remember, we have to provide a name. I'm going to go with Bruce. And he is 10 years old. Now, as before, we can access the properties of my dog. My dog dot name. We know what the name of this dog is, but we can also access the methods, and we can execute those methods. So we can say my dog dot description. Again, we access the methods using dot notation. Now, remember, there's this self thing here, right? So the object has to be provided as an argument. Now, the sort of trick here is that when we run methods like this using dot syntax, the object is here and it essentially automatically gets passed as self. So rather than you having to do something like dog.description and passing in my dog, which you can also do, I guess, and that will work because you're going to the dog class, you're taking the description method, you're providing it with a self, you're providing it with an object, which is the dog object. But essentially, a shortcut to that is to just take my dog and do dot description. So even though you're not passing the argument, because you're running it from the object, it automatically gets passed as the first argument, and it will run the same way. And just to verify that the dog can woof, I guess. There we go. So what we're going to do now is we're going to talk about inheritance. So what is this inheritance thing, right? Let's continue down the animal theme, I guess. I want to go one level higher than the dog. I want to create an animal class. Now, what we're ultimately going to see here is we can create classes like, dogs, cats, things like that, that can inherit from a parent class or a superclass. So in the base class, which in this case is just animal, we can define some properties and methods that it might have by default, and then we can make it a bit more specific when we create the dog class or the cat class and things like that. So let's demonstrate that functionality here. Let's start by saying that this is, just a generic animal. And we're going to give it an initialization function. And we're going to say, I want this to have a name and I want this to have an age. That's it. Again, as before, self.name equals name and self.age equals age. Now, this animal thing, I also want us to be able to have it do some generic stuff. So I want a description again, as before, just like we had with the dog. I can just copy paste it, actually. Let's do that. And let's have it make a noise. Now, the only difference here is this isn't a dog, this is an animal, right? So it's more of an abstract thing. Let's do generic animal noise. I don't know. Anyway, we now have animal. So as before, right, nothing really different from the dog. I can create my animal, and I can say animal, let's go with, I don't know, John. Do you really name animals John? I don't know. And he's like 50, I guess. And now if I run my animal.noise, John makes a generic animal noise, right? So this is where having child classes and parent classes can be advantageous. So down here, I'm going to start defining a new class. I'm going to call it dog, as we did before. Now, if you want to inherit from a parent class, you can just put the name of the class in brackets here. So we've got class animal here. So I want to say that I'm creating a class dog, which inherits from animal. Now, by default, you could just pass that, and your dog is essentially equivalent to an animal. So I can create my dog again, instantiate it. Again, it'll give me errors because the parent class, which is animal, expects 2 arguments. So I do need to name him John and 50 years old. And then this is functionally equivalent to what it was before. I can do my dog.noise, but this time it will make that generic animal noise again, because it is equivalent to animal. It's not like before where it was specific to a dog. So what we can do is we can say, okay, I want to create a dog class that inherits from animal, but I want to define my own methods, and I can do that. So not only can I define my own methods, like I could make a specific method to dogs here, like walk. I mean, most animals can walk, right? I don't know, but you know, walking as in walking a dog. But I can also create methods that override the original method. So animal has a method called noise, but I can define my own noise here that essentially takes precedence over this noise. And that's what we call overriding a method. So now here I can say print wolf. Now, see, this is a very small amount of code, right? All I've said is I want to create a dog, which is a type of animal, except I want it to have this noise. Now, if I run that as before, this time I do get my wolf. So now you can also make another class. Let's just put it below. Class cat animal. And here I want to override noise to be, you guessed it, meow. So now in the same way, I can define my cat equals cat Bob, who is only 10. Actually, that's quite old for a cat. And I can make the noise. This is quite powerful. It can be used to make things, you know, consistent. You know, like I said before, the example where imagine if you were making a video game and a lot of the characters in that game, a lot of the animals in that game all had certain commonalities, but you needed something specific to each character or each animal, right? And this is one way you can do that. So not only can we do this, we can also extend the functionality of our base class. So for example, you know, we mentioned earlier, we could define a walk method for our dog, right? So let's do that, even though the base class doesn't have that. Let's just print, let's make it an F string, self.name, because remember that is defined in the base layer, is going for a walk. So now our dog has an extra method, which, you know, the cat does not. So I could just do my dog.walk, for example. So now this takes the name property and inserts it into that string, because remember we provided the name upon object creation. So what is abstraction? Well, let's redefine our animal class here. Let's just put it down here. Now, as we saw before, we can instantiate instances of this class. You know, we inherited animal in our dog and our cat class, and we can instantiate dog and cat objects just fine. But we could also instantiate an animal object. And you might not necessarily want to do that, because you might not want the user to ultimately be able to instantiate something that is meant to be a bit abstract. Like, you know, you can create a cat or a dog in a video game, for example, but do you really want them to be able to create an animal? What even is an animal? You know, what kind of animal, right? And so that's why it's worth considering what parts of your code you want to abstract away from the user, right? So like we mentioned before, we can create an animal. So, you know, let's say this is a new dog now, called Eva. And Eva is 5 years old. I can do that, but Eva happens to make a generic animal noise. So we can modify our class a little bit, and we can modify it by making it into what we call an abstract class. We are going to want to import a couple of things. We're going to want to import from ABC. Now ABC stands for Abstract Base Class in Python. We're going to use two things from this. We're going to import ABC, and we're going to import something called abstract method, because those are the two things I want to use here. Now, I want to take our animal class and let's modify it. We've got our reference animal class up here anyway, right? So we've added this abstract base class as something that animal now inherits. Now what this basically does is it tells Python that we cannot instantiate an instance of animal unless all of its abstract properties and methods are overridden. So what does that mean? Well, by default, we don't actually have any abstraction going on here. So if I just ran this as before, we can still instantiate an instance of animal. So it's no different yet, but that's where this abstract method thing is going to come in. What an abstract method is it's basically something that we require the developer to override in order to be useful. And a good candidate for an abstract method here is noise, because an animal doesn't make a noise. I mean, they do, obviously, but you need to know specifically what animal it is in order for you to even be able to define that. So this is a good candidate to have as an abstract method. So how do we do that? Well, we apply what's called a decorator. If we put an @ sign here and use this abstract method that we imported earlier, what this is now saying is noise is an abstract method. It by itself doesn't mean anything, and it's something that needs to be overridden in order for it to actually be of use. Now, we don't really want to define anything here, and there's a few things you can put here. You could just put the pass keyword because like we discussed before, pass just basically skips over that line. We don't really want to define noise. Some people also put raise not implemented error like this. Now, what that does is previously, or just if you're not using abstraction, like for example, if you didn't have this would be an equivalent way for you to do something like abstraction, because what it would do is if someone inherited from animal, or if someone instantiated an instance of animal and they tried to run noise, it would error out for them. So it was kind of a way to get abstraction. Now that we can sort of have an abstract method decorator, we don't really need to actually put this here because this won't run. But I like to sort of do that by convention anyway. You're welcome to just keep it as pass, I think. If I'm wrong on that, please let me know in the comments, but I don't think there's any functional difference really in terms of what you put here. So now if we run this and try to instantiate an instance of animal, it doesn't work because we can't instantiate an abstract class with an abstract method. So we now need to define classes that have to override noise. So let's go back to our dog. And luckily, we already have this class which perfectly overrides noise for us. So if I just put that below this class, we've now got a dog that inherits description as before. It even defines its own method here, but it also overrides the noise method. So now there's no more abstraction. So if I define that, and now I create a dog called Eva, as opposed to just a generic animal, it will now once again work. So abstraction is quite a powerful thing if you want to essentially template things. You want other developers, say on your team, to follow a specific format. You want all of your jobs, for example, to have a specific method. They have to define this, otherwise it doesn't fit convention. It lends itself nicely to interactivity, but also using inheritance and abstraction and things like that, it can help you make your code base quite consistent. It can make sure that you share functionality well across your code. Like we've got this description method here which gets propagated to all animals that we end up creating. If you imagine you had some kind of data engineering pipeline, right, and all of your jobs in that pipeline needed to use a specific method, you could have something like this. You could make sure that all of those jobs have access to a write method which writes your data set to the cluster because they all inherit from the same job class, right? And that's an example I actually want to touch on, which is why I've mentioned that. So I think what I just want to touch on for the last part of the tutorial really is an actual practical example of using object-oriented to help make things consistent. I guess, in the field that I work in, data science and machine learning, I mentioned in the introduction, it's something that can inherently be quite messy, right? Like, for example, prior to any machine learning, we want to take our data sets and generate all of our features and manipulate that data so that it's ready for models to be trained, using that data. Now, those pipelines, we kind of want to keep them consistent. We want developers to be able to come in and easily understand what the code is doing. We want to be able to modify things quickly and effectively without having to modify every single job. So I think that kind of scenario is a good candidate for using object-oriented for the purposes of consistency and modularity. I'm going to open my editor, which so I use Code Runner typically for YouTube stuff, simply because it's simple and nice and doesn't have too many buttons everywhere, so it's a bit less convoluted. But Visual Studio Code is another good one. So I've got an example here where, and there's our notebook we were just looking at. In that same folder, I have a couple of files here. So I've defined some example jobs. And while this might look a bit weird at first, let's just skim through it, because it's a way of talking about how we might want to keep our, data engineering consistent, which is one of the sort of use cases that motivates the use of object-oriented, at least where I work, really. And here in a separate file, I've defined my abstract class. Let's full screen this. So like I mentioned earlier, in our data pipelines, we have various jobs. We might have one job that takes a data set from somewhere, performs certain transformations on that data set, and writes it somewhere. Those are the sort of three main stages, read, transform, write. And that is something we expect to be consistent across the different jobs. The individual transformations might be quite specific to that job. You might have one that's simple, it just adds some columns together. You might have another that's quite complicated and, generates rolling averages and, whatever it happens to be, right? But whatever job we want, what I've done here as a little example is to sort of simulate that data engineering pipeline, if you like. So we have a class, which is an abstract class. So we inherit ABC, which is abstract base class, to define what we call a data transform job. It's abstract because it's not referring to a specific job. A data transform job could be anything, right? But all of these jobs are going to have some commonalities. They're all going to have a transform method where the data is manipulated, and a write method where we write that to wherever we happen to be writing it to. I've also got a method here which isn't abstract, which is called generate, which literally just returns a data frame with random data in it. Nothing too fancy here. I could put this in a separate util function, which is where it might belong, to be honest, but I've put it here just to sort of demonstrate that you can mix abstract and non-abstract methods in an abstract base class. But other than that, nothing too fancy here. In the initialization function, we just set the output data as a property, and we just set that to none by default, because what we want is, once the job is finished, we want this to be assigned the output data so we can then do something with it. But you can handle input and output in a number of ways. Now, in the example jobs file, what I do is I import that data transform job abstract class, and I define two jobs. So here's job 1, here's job 2. Now, this is where we inherit that abstract class. We define our initialization function again. This is something I didn't really touch on earlier. This super init thing. What this does is, super is referring to the superclass. So a class that we actually inherit. So in this case, it's data transform job. All we're saying here is run the initialization function that is in the superclass. Now, other than that little tidbit, we know what we have to do, right? Whenever we define a data transform job, we must overwrite the transform method and the write method because they're abstract, right? So let's define our transform method. In this job, I just happen to run the generate method. So remember, we can do self.generate because generate is a method that is associated with this object, because this object is defined from this class, which inherits from this class, which has generate defined. I know that's a bit convoluted, but I just want to very explicitly explain where this generate actually comes from. It's a property, it's a method associated with this object because it's defined in the layer above. So that generate method is actually defined here. We give it some rows and columns and it just generates a random data set. Nothing too fancy there. And all I'm doing with this transformation is I'm defining a third column at index position 2, which is just the pure sum of the first column and the second column. And then finally, I'm assigning that as a property of our object. Now, then we have to overwrite the write method. Now, I'm not actually writing data anywhere. You could imagine if you were, in an organization or something, you might be writing data to a network drive or a Hadoop cluster or, wherever it happens to be. In this case, I'm just printing something and, printing the head of the data frame out so we can actually see it. I'm not actually writing something, but you get the idea, right? Now, in the second job, very, very similar. The only difference here is rather than generate a 5 by 2, I'm generating a 5 by 5, so it has 5 columns and 5 rows. And for my 6th column, I'm actually taking the mean of all the other columns that exist. So those are our 2 classes in our data engineering pipeline. Now, here I'm actually executing them. I'm doing all of this in one file, which you may not necessarily do in practice, maybe just because I'm being a bit lazy. But these you might have in a separate process, or you might have a scheduler that runs this little snippet of code, which is literally just to drive it. It instantiates a job object, which creates an instance of these classes. We then run the transform method, and then we run the write method. Again, these only take self as an argument, so it only needs the object because it then uses properties and methods in that object. We don't have to pass around, arguments and all that kind of stuff. So object-oriented sort of helps deal with, passing around input and output from different functions. It's quite nice like that because anytime you get an output, you can just store it as a property of the object and you're just passing the object around basically. So I can actually run this if I just go over to my run button here. And you see, so first it'll run the first job. We've generated our 2 columns of random data, and there's our third column, which will be the sum, which looks right to me in these cases. And then with the second job, it generates 5 columns, and then it produces the mean, which you'd expect to be close to be 0.5 for each of these. So yeah, that looks about right. So that's just sort of a little practical example of how you might use object-oriented to help keep things consistent, as well as, using it to write code that people can interact with and play with, say in a Jupyter Notebook and things like that. So it's very multifaceted in that sense. And I think it's a good thing to learn if you want to sort of help keep code clean and modularized. You can imagine if we now need a new transform job, we have a new data set and we want to process it, we could write it in the same framework so that it looks consistent. Now if we wanted to change our random data generator, we only have to change it here. We don't have to worry about propagating all of those changes to all the different jobs and things like that. So that's why it can be very useful. So that concludes the tutorial really. I hope it's been useful. And yeah, if you've got any thoughts on that, please feel free to leave them down in the comments and all that kind of stuff. Or if you've got any questions, I'm happy to answer them as well. And yeah, thank you for watching. So this is me from the future again. As I mentioned before, I've gone through the notebook that we went through in our tutorial and I've added, various little notes and stuff. I've cleaned it up a little bit, just in case you want to read through it and you prefer a version that provides you with reference notes and things like that. That's also available. So I'll upload that to GitHub and I'll put a link in the description. So yeah, thank you for watching and I'll see you in the next one.